Hello everyone, good morning, welcome. I'm Ria, I'm an engineering manager at Stacklok, where we've been building ToolHive, an open source project for running MCP servers in production. We've been diving into MCP, building MCP servers, trying out different patterns, and figuring out what works in the real world. And I know we're not the only ones. There are thousands of MCP servers out there, and all the major clients already have support for it. So I figured, let's start with the fundamentals this morning. Let's talk about what MCP is, why it's been adopted so quickly, and what we're still figuring out as a community. Let's start by taking a look at what the world of AI looked like before MCP. We know that large language models are trained on static data. And so they only have information about the things that they were trained on. In the world before MCP, if you wanted to give your model some additional information, perhaps about your internal expense policy, or what the weather was yesterday, or what your sales pipeline might look like, you would probably choose something like RAG or fine-tuning. But each of these had their own hurdles. With RAG, you had to come up with a vector database, which you would have to continuously re-index whenever you got new information. And you were also limited by the context window. So you could only give the model so much information before it started to get overloaded. With fine-tuning, you ran into a similar problem because you had to have this high-quality data set to start out with, and then you also had to rerun the fine-tuning every time you got new data. And this would end up being pretty expensive because you would have to pay for those compute costs every time you got new data. So both of those worked quite well for more static data, but not so well for this dynamic real-time data. Now, there was the notion of tool calling before MCP existed, but the problem was that it wasn't standardized. There were various frameworks and clients that would let you connect to external services, but just because a framework knew how to connect to GitHub didn't make integrating with Jira any easier. They would still have to rewrite the code for that integration from scratch because it was an entirely different system. And similarly, just because one framework could integrate with GitHub doesn't mean another framework could come along and reuse that work that had already been done in order for them to integrate. They had to use their own internal logic and interfaces in order to make that connection. So there were ways to do it, but there wasn't a standard way of doing it. Then along came MCP, and that's exactly what it did. It introduced a standard way for these clients and frameworks to connect to these external services. It made it so that if you write a MCP server, now all the clients that support MCP are able to connect to it. And similarly, is the mic still on? Okay. And similarly, if a client is MCP compatible and it can talk to the GitHub MCP server, then it's also able to talk to the Jira MCP server and the Notion MCP server and the random meme generator MCP server that you found on the internet. And the the power of this comes from when you as an organization choose to build an MCP server. It's now not only available to developers using a specific framework, but you can roll it out to your organization and your non-technical members as well. The reason why MCP is so useful today is because of the wide adoption that it's had. There are over 6,000 publicly available MCP servers out there, and I'm sure there are many more private ones as well. The variety of the public ones is also quite big. We have MCP servers from major platforms like your Google Drive MCP server, PayPal, Figma, Notion, but you also have MCP servers for specific use cases, these niche cases that individuals have run into, and they've written MCP servers for things like connecting to your home automation or giving recommendations for a movie to watch. The barrier to entry is low enough that if you want some kind of functionality, you can do it yourself, and you don't need to wait for a major vendor to come up with it. The adoption is also there on the client side. All of these major clients like VS Code, Cursor, Claude Code, Windsurf, they all already have native support for MCP servers, which again means that you have this one protocol that now gives all of these clients these 6,000 capabilities. So what are some things that we're doing with MCP today? If we think back to a year ago, before MCP existed, if I was talking to my ChatGPT and I asked it to help me debug an issue, it would typically come back to me with a list of things that I should try. It would tell me, run this command, look at these logs, check this dashboard. And to be honest, I don't really like being micromanaged by my AI. So today, with MCP, if I ask my AI to help me debug something, it can actually do it all by itself. It can call the GitHub MCP server to list issues and see if somebody's already reported what I'm seeing. It can use the Kubernetes MCP server to get the logs from a running pod and see if there are errors there. It can use the Fetch MCP server or the Context7 MCP server to get documentation and figure out if this is a real problem or a user error. And then it can also use an MCP server to create an issue once it figures out what it is, adding the steps that the person needs in order to reproduce the issue. And all of this without me needing to open a single dashboard or run a single command. And think about what that means from a perspective of productivity. Before I was the orchestrator, I had to run all of these commands. But now AI is the orchestrator. I'm able to just give it a goal, and then it knows how to figure out what steps it needs to take in order to accomplish it. Now, one of the reasons for the rapid adoption of MCP is that it's quite a simple protocol. The creators of MCP, Anthropic, have said themselves that they wanted to remove a lot of the complexity from MCP servers in order to make them really easy to write. So let's take a look at how something that is so powerful remains so simple. I'm not going to go over the entire specification, but I'd like to give you a quick overview so you understand what the foundation is. Now, an MCP client, something like Cursor, is just a service that's going to call the MCP server. The MCP server itself has a way to advertise different capabilities. And the three core capabilities that it has are resources, prompts, and tools. And by far, tools are the most commonly used. So that's what we're going to focus on right here. The MCP client communicates with a server by performing various actions. And usually the first action that it will perform is the tools list action. This means that the MCP server will return a response containing the tools that it allows to be called. In the example up there, it only returns a single tool called getWeather, but you can imagine more complicated MCP servers return several more tools. In a later interaction, probably triggered by a user asking, "What's the weather?" the client will make another call, this time using the tool's call action, and giving it the name of the tool. The MCP server will then do some kind of internal logic, which we'll talk about in a little bit later, and return, in this case, that the weather is rainy. And these two actions, the tools call and the tools list, are what you'll most commonly see when using MCP servers. And if you're a developer looking to build MCP servers, there are SDKs out there in all the major languages. There's a Python one, a TypeScript one, a Java one, a Golang one, and so on. And when you're using one of these SDKs, you typically only need to define the tool name and the business logic that will happen when that tool is called. So you don't really need to worry about the tools list call. The SDK will take care of it. And similarly, it'll take care of making sure that that interaction between the client and the server is compliant with the protocol. Now, I've talked a lot about why MCP is great, but it's important to remember that it's not the complete solution. MCP is a protocol, the same way that HTTP is a protocol. And if you think back to when HTTP first came out, we didn't magically learn how to build web applications. It wasn't until several years later that REST came along and actually formalized how to build scalable web applications using HTTP. And it wasn't until many years after that that things like SAML and OAuth started to emerge, talking about what authorization should look like. The HTTP protocol itself simply describes how a client can talk to a server in order to exchange data. And MCP is similar in that way. It only describes the interaction between the MCP client and the MCP server, which is that first line in the diagram. The protocol itself doesn't cover what happens beyond that. It doesn't talk about how the server will actually access that downstream data. It really leaves that up to the developer, which gives them a lot of freedom, but also a lot of responsibility to make sure that they're actually doing it correctly. It's a similar story with authorization. The protocol will cover what authorization should look like in that first section, in that first arrow. But it doesn't cover what authorization looks like between the actual server and the downstream data. It doesn't cover whether you might be able to take a credential from that first arrow, transform it, and use that new credential between the server and the downstream data. And it doesn't talk about whether or not that might be a good idea. The protocol also doesn't talk about best practices when it comes to building tools. How fine-grained should they be? How many tools should you have? It also doesn't talk about scalability. What happens if my MCP server is used by multiple users or multiple clients? The thing is, though, that it's okay that the protocol doesn't cover those things. The MCP protocol serves a specific purpose, just like HTTP does. But it doesn't mean that there's not room outside of the protocol to establish these patterns and figure out how to actually make MCP ready for production. The exciting thing is that the community is already experimenting and figuring out what best practices look like. I think that's why today is particularly valuable. We get to hear what other people have tried and what they've learned from. So now that we've gone over the fundamentals of MCP, I'll pass it on to the rest of the speakers to dive deeper into the practical parts of the protocol and talk about what the future might look like.